Good afternoon. Am I audible? Am I audible?
Yes, ma'am.
We'll just start the session. Sakshi ma'am, are you there?
Sorry, yes, ma'am, I'm there.
Yeah, so can I start the session?
Yes, ma'am, we can start, but participants till not joined because only 8 are there. The 5 participants are there only. So
So
should we?
you can wait for 5 more minutes.
Yes, ma'am, we can be.
Yeah.
Yes, Jaspreet ma'am, we can start with the session.
Okay, so today we will be doing meta-analysis. Okay, we'll be starting meta-analysis. So first thing first, wherever we left yesterday, so I would like to share my screen and take you to, of course, one of the PPTs that we are going to do today, which is computation of an effect size in meta-analysis. And if just a second. So if you've really understood what is the difference between an SLR, meta-analysis, and literature review, the literature review just summarizes a broad topic and it is absolutely qualitative, it is biased. It does not have any definite protocol to be followed when you include or exclude studies. Vis-a-vis that, a systematic review is supposed to be defined, the research objective has to be defined as a PICO. The inclusion exclusion criterias have to be noted. So it is more of a systematic method. It's more of something that comes from sciences. And the inclusion and exclusion criteria are very, very important when we are doing a systematic review paper. Now, within systematic review being a broader topic, there are many types of papers. For example, bibliometric papers, meta-analysis papers, so on and so forth. Bibliometry is again something which is very, very famous, but it's out of the scope of this workshop. What I'm going to talk to you about is meta-analysis. So, meta-analysis is the quantitative analysis part or the statistical analysis part of all the papers that you have, picked up in an SLR. Okay, And I request everyone to please keep your questions till 3:30. Today I'll take the Q&A a little earlier. So 3:30 we'll take Q&A because yesterday there were quite a few questions. Now, so the statistical part is meta-analysis. Now, in meta-analysis, what we do, so if you remember the horse example, where every horse was assigned a value. Okay, so he was assigned a particular power. So similarly, for all our studies now, we have to assign them a power. Okay. Now, how do we assign them a power? So, uh, um, what is that power that can be assigned to these? That is what is the question over here. So, different studies have different powers that we can take up. So that power that we talk of, that horsepower or that study power, is what we call an effect size. Okay. And effect size is important in a study because the p-value that you get in all the studies was not enough. So the p-value was only supposed to be a significance value, whereas the effect size is something better than a p-value that is given in each of the studies. So I'll take this now. When we say what is the effect size, so suppose there is a social sciences problem that is being studied. For example, you are trying to study, does therapy treat depression? So, a meta-analysis can only be done on a bivariate relationship. So where in an SLR, you can still, like the case was there in yesterday's paper where he was just trying to do a systematic review of green marketing. Unlike that, in a meta-analysis paper, you are supposed to be having two variables. So you will be studying the impact of one on the other through, say, 40 to 50 papers. Now, having said that, you might say that if all the papers are on the impact of therapy on depression, then the secondary data papers that I will collect have to have a value, some value of between therapy and depression. So some relational value. For example, a correlation value is very common. A beta coefficient is very common between these two variables in papers. So that is needed to do a meta-analysis. So this is what we call an effect size. So where in social science papers, when we are studying these bivariate values, we pick up correlation or beta coefficient between the two variables from different studies. In scientific studies, they pick up some other values. So, a t-test, chi-squares, beta coefficients, correlations, anything that is given in that paper, which is telling you a relationship of one factor with another, can be taken as a effect size, okay, or the power of the study. Now, how do we do the study, or what are the different types of effect sizes? So there are at least some 100 types of effect sizes. When I say that there are 100 types of effect sizes, what I mean is that there are 100 types of effect sizes in different papers. That is what I mean. So correlation is one, beta coefficient is one, standard deviation mean is another, t-test is another, ANOVA F is another. So there are so many effect sizes which can be picked up from the studies, and a meta-analysis can be done, or a consolidation or summarization of the power of all studies can be done through these values. But primarily, we divide the effect size into broadly three categories. So there is something called a standardized effect size, in which we have the D family, the R family, and the other family. So when we talk of the D family is actually the effect size which is most prominently used in meta-analysis. And this is the original effect size that was prevalent in the medical sciences. Okay, so what does the D family do? D family is an effect size where our input or where our measure of power in each of the studies is the standard deviation and mean. Okay, so if from all the papers we are picking up standard deviation and mean, then we can say it is a D family effect size. R family effect sizes when we pick up correlation values from papers. So if we are picking up from all papers, we are picking up correlation values, then that becomes a R family effect size. There's something called an others effect size where we pick up odds ratio or log odds ratio. This is also very prevalent in the medical domain. Okay, we social science researchers primarily we work on the R family. Okay, because most of the papers that we come across in social science, it is the correlation between two variables which is reported. And from all the papers that we are picking up, 40 to 50, whatever papers are there, what we want is correlation values. Okay, so we will be dealing with the R family. So although I will do the D family also, but we will be dealing with the R family. Now, before I go to R family, what I want you people to do is, and I hope you must have done it, I had sent a link to the organizers, and we had to, I don't know if any of you have not done. So you were supposed to download Meta Essentials. We had to download Meta Essential Sheets. Has everybody done that? Have you all downloaded those sheets?
Yes, ma'am.
It is downloaded. So this is the workbook that you had to download. It will come like a zip file. Okay. So if all of you have downloaded those sheets, please open up sheet number 5. It says Meta Essentials Correlational Data. Please open sheet number 5. It says Meta Essential Correlation Data. If you have opened it up, please say yes. If everybody's opened it, please say yes.
Yes, ma'am.
Okay, what about the rest of the participants? From the zip folder that you downloaded, just open sheet number 5, Meta Essentials Correlation Data.
From that Excel, first one is input, then forest plot,
Input, open to input.
open input. Okay, ma'am.
Don't worry about these highlights that you see. These have been put from my paper, so you will get a standard input. If you've got it, just say I've received it.
Yes, ma'am.
Ma'am, it's not a zip file, it's a Excel file
Yes, this is an
in
Excel
which
file.
it is input, forest, plot, subgroup analysis. This one, ma'am.
Yes, input, open to input.
Okay, ma'am. Thank you.
Ma'am, this one meta essentials correlational data. 5.
Yes. File number 5. It says 5 meta essentials correlational data. Has everybody done?
Yes, ma'am.
Okay, so I'll go further. Now I'll show you my paper, which I which I have constructed. I was working on the topic of urge to buy. Yeah. So what I was doing is that I found a few papers on impulsive buying, but there was no paper on urge to buy. So I was wanting to study, my research objective was to study the factors impacting urge to buy. Okay, this was my research objective. And the population was every product. So anywhere, if they're talking about a product, be it luxury, be it services, be it banks, airlines, products, anything, that was my total population. Now, the first thing that I did is, after I collected papers, so in the when I came down to say 40 to 50 papers, the first thing that I did is I made an Excel sheet like the one you see on your screens. So here is the title of the paper, author of the paper, journal name, year of publication, context of study, theoretical model, scale, location, model analysis, anything and everything that you find in the paper which you feel could act as a moderator, or you feel that could differentiate these papers from each other, please do write it down. Okay. Now in this paper, what I found is, suppose it was the first paper. This is my first paper. So I found out that, urge to buy in this paper was getting impacted by perceived enjoyment. So in this one paper, I found the correlation value of urge to buy and perceived enjoyment. Also, in the same paper, I found out the correlational value of urge to buy and perceived usefulness. So, two factors affecting urge to buy, I found out from this paper. When I went to the second paper, so this is my second paper. When I went to the second paper and I read it, full reading, I found out the correlational value of urge to buy and perceived enjoyment, and urge to buy and perceived usefulness. Okay, again, coincidentally, same variables. The third paper that I went to, there I found a correlation of urge to buy and scarcity. Okay, so basically, what was my research objective? My research objective was to find out all the factors which impact urge to buy. Different papers are giving me different factors. But what is important over here is that I need a correlation value between these two factors. Okay. I'll give you another example of a paper which is in the pipeline. This, of course, has gone for publication, but that is probably a better paper, and this sheet that I'm about to show you has been made by Dr. Neeraj Kaushik. So as I said, he's the best person on meta-analysis. Yeah, so now this is another sheet that we made. So for different papers, we can have different formats. Okay, but because Kaushik sir has taken the pain to make these sheets, and he'll be more than happy if I can show it to you people, if it helps you in any way. This is the sheets we are working on. for a paper. Okay, and the paper is on IMO, internal marketing orientation. We are trying to do a meta-analysis on it. So the first thing that we are doing is look at it. Study number 1, you number the study, the title, name, year, sample. So from where have the samples been collected, the number of samples, and then the relationship. So these are correlation, the correlation between IMO and other factors. So here our research objective is to analyze what are the factors, antecedents, and consequences of IMO. So we are trying to make a conceptual model also after reading all these papers, and we will also do a meta-analysis of the same. So from the first paper, see, we have got so many correlations. Sir has also made the sheet not only of correlation but of significance, where in every correlation I have to say whether the study was significant or not. He's also made a column of R squared, beta coefficient, etc. So, if you don't, suppose within this one relation of IMO and another variable, you don't get a correlational value from the paper, you can pick up R squared, beta coefficient, etc. So much so that presently, when I was working on this paper, so you can see what sort of an exhaustive work goes into this. So this is the second paper. Okay, these are the bivariate relationships I found out, correlation values. This is the third paper. Okay, all details of the third paper, then correlation values between the two variables, correlations. So you can see this has as yet been done for 40 papers. And there are another 55 that I have to finish, and we are going to complete this sheet and we are going to do a meta-analysis. Another thing after this has been done is there's another sheet that Sir has created where we number the relationships also. So ID and IMO, the relationship that I found in the first paper, I'm going to call it relationship number 1. The second relationship, IMO and variable, I'm going to call it relationship number 2. So how many ever relationships we get from these supposedly 95 papers, we are going to list them like this. Okay, so right now, because I've done just 40 papers, I've got some 27 relationships, and when I finish it, these will be like huge. So all these relationships are with IMO. Okay, so as I said, the topic of my research paper is antecedents and consequences of IMO. So all these relationships will be only and only taken in relation to IMO, not other factors. Correct? So this is the way we develop sheets for meta-analysis. Now, once we do this, so I'll just take this as a simpler version, so I'll work on this first. Now, once we have, written down the relationship, so, we know the dependent variable and independent variable, and because we were studying the urge to buy, factors affecting urge to buy, we write the correlation of all those factors, scarcity, perceived enjoyment, etc. And we do this for all 40. So this sheet that you see over here will be made for all 40 studies or 60 studies that you have taken into consideration. After you have done this, so this is the first step. After you have done this, you will consolidate the sheet into separate bivariate. So now what you will do is you will make a separate Excel table of only the urge to buy and perceived enjoyment relationships. Okay, so you will make now the table for urge to buy and perceived enjoyment, and I had received some 7 values from the 40 to 60 papers that I had included in my study. I will write down the correlation value and sample size of all of them, and I will just copy. So what I'm doing is right click and copy, and I'm just going to copy them to my meta essential sheet. That's exactly what I've done. I've just copied them. If you see, I have just copied them into the meta essential sheet. Two columns I need. One is correlation and one is the numbering. Okay, these are the two columns that are essential: correlation and number of subjects. Okay, number of subjects means sample size. Somebody is not on mute. There's a disturbance. Somebody is not on mute. Yeah. Yes, is somebody saying something? Okay. So the thing that we have taken from this Excel sheet, and mind you, this has only been done for one bivariate relationship. If in your paper you get more relationships for urge to buy, I'm just showing you two. There was another relationship we got which was perceived usefulness. I got 3 papers out of the set of 40 papers that I had. So on and so forth. I found some 8 variables which had a relationship with urge to buy. In some places there were 7 papers, some places 8, some places 15. Mind you, this whole process of meta-analysis that we are going to do on meta essentials has to be repeated for each single relationship. Okay, so for all relationships individually, you will have to do a meta-analysis. Okay, now this is what I've copied. Okay, and now let me go to, if you've copied this, so I'll tell you the columns. One column is the study name. So whichever studies they are, you can write the author's name. If you do not want to write it, you can name it as A, B, C, D, E, F, G also. Include study, by default it says yes because you've put in a study. So by default it says yes, include the study. Correlation value, this whole table is for urge to buy and perceived usefulness. So these correlation values, all of them are urge to buy and perceived usefulness. Number of subjects is the sample size of that particular paper. So in Sheeran's paper, the correlation value between urge to buy and perceived usefulness was 0.3, and the sample size of Sheeran's paper was 248. Okay. Is the data sufficient? By default, it is yes. Okay. So if suppose, just a second. Okay, 240, sorry, 248. This by default will be yes. Subgroup analysis and moderator analysis I'll not touch right now. The only data that we need over here, or we need right now, is this. For your sheets, you don't have to do this. This is just because I was explaining how I bring my data as in my papers data to the meta essentials. In your case, you might be having already a sample uh, a sample input. Please use that to understand the concepts. Don't change those inputs. They have already been inputted in the input sheet. Okay. This numbering has to be, so 7 papers, 7 values. These values have been taken, as I said, from here. Okay, my consolidated sheet. Now what do I do with these values? Or if these and this correlation that you see is actually that horsepower of each and every horse, or the effect size or power of each of the studies. In this case, to judge the power of each of the studies, we are using the value of correlation. Okay, now after this, you go to the next sheet, which is forest plot. Okay, and it is already made. The good thing about Meta Essentials is it's free of cost and you don't have to do anything. You just have to go to the next sheet and the analysis is done. What is important over here is the interpretation of this analysis. So when you go to the forest plot sheet, the first thing that you have to see is the combined effect size. I have, just give me 1 minute, let me remove the other highlight so that you can see. Now the highlighted point that you see, combined effect size correlation 0.33. This is the consolidated effect size or the consolidated correlation of all the 7 studies taken together. But there are a few more terms that you have to see. So when we say that this is the combined effect size of all studies taken together, it is not a normal average. Okay. Why I say so is because if you see, there's a column by the name of weight. Okay, so there's a column by the name of weight. I've just highlighted it. You will see that each and every study has been given a weightage. So if you remember in 10 standard or 12 standard, when we had some subjects, there were always some subjects which were given high weightage. So I remember maths and science were always given the highest weightage. Hindi, poor thing, and English languages were always given a lesser weightage, even while preparing for them when it came to marks. So similarly, there are some studies which have been given a high weightage and there are some studies which have been given a lesser weightage. Now, you might be thinking that why such a high weightage to say study number 5. So I've just highlighted study number 5. It stands with the highest weightage of 24.05%. On the other hand, study number 4 stands with the smallest weightage of 6.65. Now you must be thinking, what is the basis of giving this weightage? So if you want to know the basis of giving the weightage, the basis of giving the weightage is the sample size. Let me explain. So keep your eye on study number 4, which has the least weightage, and study number 5, which has the maximum weightage. Now go back to the input sheet. Okay, just note down the sample size of study number 5. It's 201, which is the least from the whole group. Vis-a-vis that, look at the sample size of study number 5. It's 720, which is the highest among the group. Okay, and in a similar way, the study weightages for the 5th study is 24%, highest in the total group, and the weightage given to study number 4 is 6%, lowest in the weightage group. In a fixed effect model, I'll tell you what's fixed effect and random effect, but right now for a simple understanding, please understand. In meta-analysis, we have 2 types of models. One is fixed and one is random. There are some assumptions to fixed, there are some assumptions to random. As per the fixed effect model, the higher weightage is always given to the study which has a higher sample size. Okay, so these weightages that you see in front of you are not being given on the basis of whether the paper is good or bad or A category or B category or published or not published. No, the weightage is not assigned by the researcher. The weightage is being calculated by the software on the basis of 2 values that you have given it, one being correlation and second being sample size. That's it. Okay. Another parameter that you see over here is the lower limit and upper limit. So this is what we call the confidence interval. Okay. Now the confidence interval means that suppose I'm taking 0.30 as an effect size of Sheeran's study between urge to buy and perceived uh, uh, ease or perceived helpfulness. The upper and lower limit to this, or this particular effect size or power of the study, could vary from 0.18 to 0.41. Okay. Similarly, in the second study of Belk, where the correlation value between, again, urge to buy and perceived usefulness is 0.38, The confidence interval, which means that the effect size of 0.38 could vary from 0.28 to 0.46. That is what the lower limit and the upper limit or the confidence interval mean. Another thing that is very prominent over here is what we call the forest plot. So this is a forest plot. If you go a little right towards the Excel sheet, in the forest plot sheet itself, you will see this forest plot. Now, I'll just tell you how to interpret this forest plot. The green ball that you see over here is the combined effect size, which in our case has come out to be 0.33. The software has computed it to be 0.33. And these blue, balls that you see, these blue color bubbles that you see, they are the weightages assigned to each and every study. Okay, so if study number 5 has been given the highest weightage, just see the line of study number 5. Okay, the bar chart shows that it has been given the highest weightage, and even the bubble for the weightage of the study is huge, which of course means that the maximum weightage has been given to this study. Vis-a-vis that, if you see the the blue ball or the bubble of the 4th study, you will see that it's very, very minute. Okay, that is because it has merely been given a weightage of 6%. Okay, so these balls that you see in a forest plot represent the weightage given to each of the study. Apart from these, you do see the horizontal lines. So the horizontal lines that you see with each study is the confidence interval. So that is the reason the horizontal line is actually from one corner to the other. Okay. Also, please note that those studies which have a smaller sample size, like study number 4, study number 1 to some extent, you will see that their confidence interval or their horizontal line is too big. Okay. Vis-a-vis that, the study which has a larger sample size also has been given a larger weightage. Their confidence interval is shorter. Okay. Now, having said that, we can say, sorry, having said that, we can say that the studies where the sample size is less are less precise. Okay, why I say less precise is because their confidence interval is too huge. So it is like, for that matter, in study number 4, the confidence interval is huge. So it varies from zero point 0.3 to 0.53. So just imagine if a student comes to you, and says, okay, I got 40% marks in your examination. Next time he comes, okay, now I got some 53% in your examination. Next time he comes, he says, I got 30%. Now, will you call him a reliable student? Will you call him a precise student? No. Reliable students, precise students are those who are turning up either with a 40% every time in all assessments, or are turning up with a 90% in all assessments. Okay. So here also, when the sample size is small, the precision is also small and the confidence interval is too huge. So despite the fact that we are saying that this is the effect size of this study, we can't be sure because the confidence interval varies from 0.3 to 0.53. Okay. Vis-a-vis that, in a study which has a larger sample size, like study number 5, which has also been given a larger weightage. Okay. In such studies, the confidence level is smaller. So we know that if we are saying that study number 5 has a correlation value of say 0.6 or 0.13, we know that it will only vary from zero point 0.1 to 0.24. That's it. That is what the smaller horizontal line is showing. Okay. I hope these concepts are clear. If they are, we can go back to our PPT. Now, the R family effect size, which we have just calculated. For the R family effect size, what do you have to take from each of the papers? So my paper just showed you that you have to take the correlation values. But how to take correlation values? So on the right side, you see something called a correlation matrix. You will find this in all your included papers. Okay. Prisma, yesterday I had told you that at the end he was left with some 41 papers. But he said that when I fully screened them, I did not find the value. So here we say statistical value or the correlation value between the two variables that we were studying in say 10 papers. Now, if the correlation value is not there, I will have to discard these papers. So first I'll write to the author or else I'll discard this paper and my meta-analysis will be some 31 papers. Okay. So this is a correlation matrix that you have to see. In my paper, urge to buy and any correlational value of any other factor except for urge to buy is something that I have picked up from these papers. Okay, and then you make an Excel sheet that I've shown you already. After you see the right side, you find a correlation value of each and every bivariate and you convert it into an Excel sheet that I have already shown you. Values of ANOVA, regression, p-value, Fisher Z, etc. can also be taken. But ideally, what we do is that we take the Pearson correlation from all the values. This forest plot I have already explained to you. Sometimes you might find the forest plot in the shape of a bubble, the way it was shown. In some other softwares, you might find the forest plot in the shape of the squares. So be it the bubbles or the squares, the end result is the study with the highest weightage will have the biggest square. Okay. And in the forest plot, the diamond that you see or the rhombus that you see, that is the consolidated effect size, which in our case came out to be as 0.33 when I was on the meta essential sheet. So this I've explained to you. All values of correlation that we give to the software is converted to Fisher Z. Okay, Fisher Z is a standardized value, okay, which is not dettered with sample size. And after it is converted to Fisher Z, a summary of Fisher Z is later converted back to correlation. I'm just telling you the process of what the software is doing. Okay. Those of you who really want to know what is happening behind the software, so if you really want to know that what is happening behind the scene, these are the formulas of Pearson to Fisher Z, covariance, which has to be calculated. Okay, that's 1 upon n minus 3, n being the sample size. Standard error, which is the square root of variance, weighted mean, upper confidence level and lower confidence level. All these formulae have been taken from a book called Borenstein, okay, 2009. And Borenstein does have another edition of 2011 also. So if you do take these formulas, you will have to write in the paper also that these are the formulas I use to calculate effect size. And this has to be done. I'm telling you from my experience that, there was once um, a paper I was studying, okay, a paper of a very famous person, foreigner, I was studying, and although I did this calculation on a software called meta-analysis, a comprehensive meta-analysis, my results didn't match his paper. So I wrote to that person. I said, "Sir, with all due regards, I got so it was a I was trying to solve that paper when I was learning meta-analysis last year. So I said, sir, with all due regards, your results don't match that of my paper." So he wrote back to me that, do you think the results are wrong? So I said, no, sir, that's not what I mean. I am myself a learner and I'm trying to see, I've taken all your papers and I've calculated a consolidated effect size from the formulas that I had from Borenstein, and the consolidated effect size is coming 0.33, which does not match your paper. Okay, so then he sent me way back when he made that paper 10 years back. He had worked on another meta-analytical software. He sent me the name of the software and he sent me the formulas that he had used in that software. Okay, so he sent me the software and the formulas. And then when I saw that, I came to know that genuinely different books have different formula and different softwares have different formula, and that is the reason that if you don't use this software, which is will that is the reason that when we form a paper, we always, I actually copy these formulas from Borenstein and I write them down that these are the methods in which I've calculated these values. Okay, although I have done nothing, and the meta essential itself has done everything. It's a Excel macro, so specially made for meta analysis, and it's self sufficient. I don't have to do anything in that. Okay, now once you get a value, so over here in the meta essential sheet, we had received a value, so we got a value of 0.33, if you remember. Okay, so now that we have got a value of 0.33, the next thing that we have to know is interpreting it. Just give me 1 minute. Yeah, so now that we have got a value of 0.33, what is the interpretation of this? You've got a value, that's okay, but what is the interpretation? So Cohen D, who's the almost we can say like the father of meta-analysis or effect size. Cohen D says that if your effect size comes out to be somewhere around zero point 0.1, it means that this is a very small effect size between the two variables. Here my two variables are urge to buy and perceived usefulness. He also says that if your value is somewhere around 0.3, the effect size is medium. So you can conclude that the effect that one variable puts on the other is medium. And if it is somewhere around 0.5, then you can conclude that the impact of one variable on the other is large. Okay, so now in our Excel sheet, because the effect size has come out to be zero point 0.3, we can say that urge to buy and perceived effectiveness have a relationship or have a strength of relationship which is medium. Okay, now how is this different from any of those papers that I have taken, where the papers are individually finding out the correlation between urge to buy and perceived enjoyment? My meta-analytical paper is finding the strength of that relationship after the summation of 40 papers taken over a span of 20 years. That is how my paper is different from those individual papers, all of them, 7 papers. Okay, all those 7 papers were trying to find out the effect of perceived effectiveness and urge to buy. Then how's my paper different? My paper is different because I have found out a summation of the past 20 years of research on urge to buy and perceived effectiveness. Okay. Also a second type of effect size, which we call the D family effect size. Okay. A D family effect size, if you want to calculate a D family effect size, you will have to accumulate all the papers which have been done on the technique of experimentation. Like in our family, we wanted papers where correlation is reported. Here we want papers where standard deviation and mean is reported. And that standard deviation mean has to be only of experimental studies which have been done on two groups of people. One, the control group, and second, the experimental group. Okay, so I will pick up only those studies where the population was divided into two groups and the standard deviation and mean of each of the groups was collected. Here, to calculate the D family effect size, I cannot use a single paper of correlation. All my 40 to 50 papers have to have this value that I'm talking about, because in a D family, my effect size is the standard deviation and mean given in these papers. Okay, I can also take some other values like t-test from these papers, and I'll show you the Excel sheet first of this type of papers. So for this, you can go to, just a second, in your sheets that you have, you can go to sheet number 3, Meta Essentials, Differences Between Independent Groups. Please go to sheet number 3, Meta Analysis, Differences Between Independent Groups and Continuous Data. Okay, and if you open this sheet, you will be able to see in input there are so many inputs. So you can take an M1 M2, which is mean 1 mean 2, standard deviation 2. These are M1 M2 is the mean of control group and mean of experimental group. S1 S2 is the standard deviation of mean standard deviation of control group, standard deviation of the experimental group. Okay, you can take T values, you can take F values, Cohen D, Hedges G, anything that is reported in the paper, you can take this. And you can take different data from different also. So from this one paper, you see he's got M1, M2, S1, S2, N1, N2. N1, N2 is sample of 1 and sample of 2. Sample of control group and sample of experimental group. In the third paper, he got a consolidated M2 minus M1. He didn't get M1, M2 separately. He got an M2 minus M1, mean of one group minus mean of the second group. Here the two groups are being referred to as control group and experimental group. Then he got the standard deviation of one group and standard deviation of the other group. And he got N1 and N2, which is the sample size of one group and sample size of the other group. Yet again, in the fourth one also, he gets difference of mean and the standard deviation pooled value from the paper. Even this can be taken. In the fifth paper, he did not get anything. He got the T value between these two groups and the sample size of one group and sample size of the other group. Okay, so basically what I'm trying to say is this, the D family effect size is the most flexible, and there's a reason for that, because D family actually comes from the medical sciences. Ever since meta-analysis started, the doctors or the pharma people actually always found out the D family effect size. The R family is only and only very minutely used in social sciences, but because this comes from the medical domain, the main type of effect size that is picked up and calculated is the Cohen D effect size. Also, if you go after this seminar, if you intend to go to YouTube and see videos, you will get n number of videos on how to calculate the D family effect size. But you will not get, when I was teaching last year, I did not get a single video on how to work on the R family, because that is what social sciences people, management people needed. Okay, so that is how I learned slowly and gradually. And now, of course, you have there's my YouTube channel where I do upload most of the FDPs that I do wherever an institute gives me a permission to. And there are Neeraj Kaushik sir's videos on meta-analysis. They are in Hindi, but they are also available if you want to really understand. And he's, as I said, he's done much more work than what I've done. So very small, very simple videos are there. The formulas have been explained in that, so that can also be watched. So now, at least this year, we don't have any videos on R family, but last year, the only videos which were very prominent on YouTube were the Cohen's D effect size. Okay, so the interpretation of Cohen's D effect size, like in the R family when we had interpreted, there's a little bit of difference in the interpretation of the Cohen's D effect size. Uh, Cohen D effect size, if it is somewhere around zero point 0.2, it is considered to be small. If it's somewhere around zero point 0.5, it is considered to be medium. If it's somewhere around zero point 0.8, only then it is considered to be large. Okay. Why I say so is because why I say so is because um, in medical sciences, where this study, experimental studies are majorly done in medical sciences, not that you can't use it. If you can get 40 papers of your domain, where all the papers have been studied with an experimentation design, even you can take up this paper. But in most of the papers in medical sciences, the this consolidation of results that we are doing through meta-analysis is a matter of life and death. So when I gave you the example of that a vaccine yesterday, the children's vaccine which has to come to India, if you are consolidating research or if you are summarizing research for that, you can imagine, that how critical it is, the interpretation of the effect size. That is the reason that only if the effect size is zero point 0.8 or above, then we say that it's a large effect, so bring in the vaccine. But in social sciences, there is a difference in the effect size interpretation, which in even if it's zero point 0.5, it's okay. We say there is a large amount of impact on one variable of the other. So if you are feeling that these interpretations are different for R family and different for D, you are correct. But the reason is that experimental studies generally were done on medical sciences. And unless and until we are not 80% sure, so zero point 0.8 means I'm 80% sure that this affects that. Unless and until an 80% assurance wasn't there, the medicine or the vaccine could not be applied on a patient. So that is why a variation in interpretation of the results. These are the formulas. Again, they have been taken from Borenstein in case you want to manually calculate and see how manual calculations are done. Of course, these slides and meta-analytical material I have already sent to the institution, so you will be getting it shortly. Um, Here, the if you see the formulas, whether it's standard difference, pooled, calculation of standard error, or calculation of Cohen's D or Glasses G or Hedges G, these are other effect sizes of the D family. Any of these, the values that you need are those four to five values. So you need an SD1 standard deviation of the control group, standard deviation of the experimental group, N1, N2, sample size of the control group, sample size of the experimental group. Um, uh, uh, the next thing that you need is M1 and M2, mean of the control group and mean of the experimental group. So that is what M1, M2, N1, N2, SD1, SD2 means over here, if you want to understand the formula. Yeah. So I'll end it here and I'll open the house to any questions. And yeah, no, one thing I'm left with. So once you've put this input, okay, once you've put this input in the D family effect size, meta-essential differences between independent groups, once you have done this, and then when you come to forest plot, the basics are absolutely same as they were for correlation. So, you know, here again, let me remove the highlight. Sorry. Here again, you can see that you have highlighted the combined effect size. Again, you see that each of these studies, let me convert this to fixed effect model. You see that each of the study have been assigned a weightage. The weightages are high or low on the basis of the sample size of each of the studies. Here again you see that, oh sorry. Again you see that there is an effect size calculated here. They are calling it hedges G. There is a study name column like it was last time. There's an upper and lower limit again the way it was previously. If she is at the forest plot, even the forest plot is very similar. So what I mean to say is, in any of the sheets that you've got, all the 6, 7 sheets that you've got are of different effect sizes. I've explained only 2. But whichever effect size it is, the only difference you will see in the sheets is the input sheets. By the time you bring that sheets to forest plot sheet, all sheets, irrespective of what the input was, will remain same. And all the concepts, be it of consolidated effect size, be it of weightages given, confidence interval, upper limit, lower limit, forest plot, all those concepts are also same for all 100 types of effect sizes that are there in the world. Okay, so this is what is effect size and how we calculate it. Of course, I have to show you how we report it. So I'm opening a paper of meta-analysis that I generally take as a sample. Okay, so this is a paper of theory of client behavior. It's a very common theory in social sciences. It says systematic review and meta-analysis. Remember, I explained to you the second chapter, methods, and even over here we have methods. The concepts of SLR remain same, so he has to write the Prisma, he has to write the Pico over here also in meta-analysis. He has to define his population intervention comparison and outcomes. He has to write that I took the data from these many databases. Those concepts that I did with you yesterday, they stand. They stand. He also has to make a prisma. So like in an SLR paper, simple SLR paper, even in a meta-analysis paper, you're supposed to be making a prisma. Correct? So those basic concepts are same. The little variation that is there, so data extraction again, that also was there yesterday. I'm not repeating it. In the analysis part is something that, you know, so just see, he says, I calculated the pooled effect size by so and so method, and he uses the word Borenstein et al. 2009. So, you know, he's telling which are the formulas that he has used for calculating the effect size. Further, let's come to, okay, Prisma, you know, and this is the table that we are working on. So we have done this table. So N, which is the total um, number of sample studies for a particular relationship. So here he's done it on attitude and intention. If you remember in our sheet, we were doing it for perceived enjoyment and urge to buy. So if I summarize, so this is my sample, just a minute. This N, just a second. Yeah. So the N over here becomes, 3002, like 6117. So N means for this particular relationship, bivariate relationship, how many ever papers I had. In this case, I had 7. What's the total sample size of all 7 papers taken together? K means the number of papers, so number of papers for him in this one relationship of attitude and intention that he found out were 19. In my case, they were 7. R plus means the consolidated combined effect size. In his paper, it came out to be for attitude intention, it came out to be 0.61. In our Excel sheet, it came out to be 0.33. The confidence interval, which is the upper and lower limit of the consolidated effect size, where do you see it in Meta Essentials? You see it over here. So this is the combined effect size 0.33, and here you see the, this is it, 0.29 is the confidence interval lower and 0.37 is the upper. So that is exactly what has been reported in this paper. So you write the consolidated effect size, and then you write the confidence interval, the upper and lower limit of the confidence interval. So these are the 4 columns that we have finished today. What I have to do with you tomorrow is the heterogeneity. So Q, finding out the value of Q and I square. This will come after an explanation of a concept of meta-analysis, which is heterogeneity. So it's not that we have calculated the consolidated effect size, we have interpreted it according to Cohen D as small, medium, big, and our work is done. No, it's not like that. Um, we will have to further, get into more analysis of these 40 to 50 papers which we have collected for meta-analysis. We will have to judge whether they have a heterogeneity between them or not. So, which is basically a pattern that we report in papers, and we will have to report that numerically or statistically with these measures called Q and I. Also, you see on the top of the, here, you see he says I used random model. Okay, but in our study today, we had used a fixed model. Now, what is this random model? What is the fixed one? And which one to use out of the two? That depends on how heterogeneous is my data. So tomorrow when we start with heterogeneity and that and I square calculation and Q calculation, that is the time I'll be taking you through what is a fixed model and what is a random model, because what happens is that in a fixed model and random model, the effect sizes change. If you want to see that yourself, uh, in this place which says meta-analytical model, I'm just highlighting it. So see this place, it says meta-analytical model. Just below this, you have a drop down where you see fixed effect model. So right now in the fixed effect model, my combined effect size is 0.33. If I drop down and make it random, it changes to 0.35. So the moment you see a fixed effect, that's a different effect size. When you see random, it's a different effect size. Now your question might be which one to take. Okay, because there are 2 different effect sizes, 2 different calculations, which one to take. That is what I'll be taking tomorrow when I explain to you the total concept of heterogeneity in data. So it's not that we just calculate the overall effect size and report it. There are many more things which have to be done to make a meta-analytical paper. Okay, so I'll come back to questions now. We can.
Excuse me, ma'am.
Yes, yes.
Actually, ma'am, in some papers, like correlation value is not given. In some papers, they have done SEM, and in SEM, they have used discriminant validity, where correlation matrix is visible. So, can we take that value and use it for analysis?
In the correlation matrix itself, the values that are there between the two variables are Pearson correlation values.
Yes, ma'am. That is what I'm saying. I can take it from that place also, no?
Yes, we have to take it from there. We have to take it from there.
Okay, ma'am. Thank you.
Any other questions?
Hello.
Ma'am, the exercise you have just now shown, you have find out you have actually gone to find out you have actually used correlation between urge to buy and perceived enjoyment. And
Yeah.
after that, there is another table which is highlighted in green color. That was urge to buy and perceived usefulness. So we will repeat the same exercise for this also.
Yes, ma'am. And there are 8 variables. The paper is not published yet, so I can't show all 8 variables. But we will repeat this 8 times. We repeated this 8 times for 8 different bivariate editions.
Okay, okay. Thank you.
Ashwini sir, you have your hand raised. Can I also request everybody else to raise your hands for
Hello.
the number of questions? Yes, Ashwini.
Yes, good afternoon, ma'am. So, ma'am, I just want to know, when taking the papers, is there any rules to whether that correlation value is significant or non-significant, whether we have to choose the paper or to drop the paper, about the significance? The correlation value is there, but the significance is there or not? I am not sure, but they have not given, or they have given, but this is not significant. So what should I do?
The significance is not that important. This is an additional column that is not important in my calculation. Am I audible?
Sorry, ma'am, what you have said, just I have not able to get.
So the significance value is not that important to paper. So when I
Okay.
do my calculation, so see, look at my calculation. These are my calculations with correlation. I have not used the p-value at all. Okay, that is only for my reference to see whether the value was significant or not significant. That is just a reference column. It has nothing to do with the calculation of an overall effect size.
Yes, madam. Another query. What about if the correlation? Hello. If there are various studies, some of the studies are positive correlated, and some of the studies given the negative correlation value. So,
Yes.
what should be done there?
So positive and negative have to be written as it is. So positive 0.5 or negative 0.25. So it has to be written with the sign into the Excel sheet. With the respective sign of correlation, they have to put into the sheet.
Then rest things will be remain as per the described procedure.
Yes, sir. Yes. Sir.
Okay. Thank you.
Rest of the participants who have any questions about anything, be it today's session or yesterday's session, please raise your hands. Yesterday there were a lot of questioning, so that's why I've given you enough time for question answer.
Good afternoon, ma'am. Am I audible?
Yes, yes, you're on.
Ma'am, actually the meta-analysis is done on the quantitative paper only. right? So in those papers which are having quantitative tests like correlation, regression, z test, t test, we have to take. But in the what you have taught today, I got to know that we have to see only the correlation part for the R family. That means in every paper only I have to see only correlation between them. I do not have to do anything with the z test, f test, whatever the paper is using. Hello? Hello? Hello?
Jaspreet ma'am, are you there? Uh, I think Jaspreet ma'am has disconnected. I think she
Okay.
will join again. She's joining again. Yes, ma'am is there.
Am I audible now?
Yes, ma'am, you are
Yes.
audible.
Yeah, can you just repeat the question, Anjali? I got disconnected.
Yes. Ma'am, can I ask now?
Yes, yes, please ask.
Ma'am, actually, I just wanted to know that if we take quantitative paper, means when I see the quantitative paper, I see many tests in that paper. So I have to take only correlation between the things, or I have to take the F test, Z test also.
If you see another test in the paper, you will have to convert it into correlation. Okay,
Okay.
so if I say that, there's a t-test or something, it has to be converted into a correlation. So
So
for
we
example,
have any? Yes, ma'am.
there is no software for this, at least in this context, it can't be done. For example, in Meta Essentials, it can't be done. But there are paid softwares. For example, there's a paid software by the name of Comprehensive Meta-Analysis. I'll just show you the site of that also. So I'm just showing you that. In that, there is an option of automatically putting t-test, etc., and it will analyze, because it will change it into the correlation value. Okay.
Okay.
Have I shared
Okay,
my
ma'am.
screen? Give me 1 minute.
No,
Have I
ma'am,
shared?
your screen is not shared.
Let me share it. I'll show you. So this is comprehensive meta-analysis. Okay, this is a paid software. In this, what happens is when you do put t values or an OIF values or beta coefficients, etc., it automatically changes it into a correlation. But in other points, you will have to do it manually. So, for example, the standardized beta coefficient plus 0.05 is what we say that we have to add to make it nearest to correlation. Okay. Similarly, when a
Okay.
t-test is to be changed into say correlation, there's a particular formula for that too. Okay, I think it's 1 upon 1 minus n, something like this. So even for a t-test to be changed into a correlation, there are formulas. So in meta essentials, the problem is that this will have to be done manually. Okay, so you'll have
Okay.
to manually. But in or what you can do is there's one more method of doing it, but it's a very advanced method. So sometimes what happens is that when we are collecting data between two variables, we get different sort of papers. So we get 10 papers of correlation, some 10 papers of t-test, another 10 papers where standard deviation mean is given. Okay, so what we do is we find out two types of values. So for half the papers, we find out, say, R value, and for half the papers, we find out D value. And then there are conversions, given in Borenstein's book, where a D value can be converted into an R value, or an R value can be converted into a D value. Such conversions are possible, but that's a very, very advanced level. Even in my papers, for what I have done, or the papers which I have seen in social science, in the topics that I work in, Mostly I have seen that people have worked on correlation and beta coefficient. See,
Okay.
yeah, either you are given correlation, if you're not given correlation, most of the places I've found a beta coefficient. If I've got a t-test, I have, for example, in this paper that I showed you, 40 papers, in 2 papers I got a t-test. I didn't get a beta coefficient, and you have to get a standardized beta coefficient. The unstandardized beta coefficient won't work. So most of the papers I got a beta coefficient, I got a correlation. They are always reported. They are always reported in social science papers. In 1 or 2 papers, I got a t-test. So I have manually converted it and then converted it into correlation value. And then I have put it into the meta-analysis sheet.
Ma'am. Got it, ma'am.
Yeah. Yeah.
Thank you.
Thank you. Any other questions? Okay, also, except for Meta Essentials, there's another free software which can do Meta Essentials, which is our software. Essentials. For me, the best method to do is Meta Essentials because it's very, very simple. It's almost like working on any Excel sheet. So I use Meta Essentials. But if you're good in coding, if you're good at coding, you can use the free software of R also. It is called Meta for doing meta-analysis. Okay? Yes. Any other doubts? Am I audible? I hope I haven't lost you people in between.
Yes,
Yes, ma'am,
ma'am,
you're
you're on.
audible.
Okay. Okay. Yeah. Any further doubts? Anything in yesterday's or today's session?
Ma'am, I think there is no doubt. So,
Okay. Okay. So I think we can end it a little earlier today. And tomorrow, I think, because it'll be the last session, probably.
sorry, ma'am, you are not audible properly. Yes, all the participants, am I audible?
Yes, you're audible.
Ma'am, actually, just want to ask something. Are you comfortable with this time for tomorrow? Because tomorrow is a holiday, as ma'am was saying. This is a Diwali weekend, so हम इसे morning में shift कर सकते हैं या फिर you are comfortable at this time?
I, in fact, had to ask this thing only because since yeah, tomorrow is Sunday, so people would be free in the morning. I think it would be better if we get free by the morning session itself. Because
Okay.
if others agree, yeah, if others
Okay.
agree.
Rest of the participants, please again,
Ma'am,
please
I'm
send the.
agree.
हाँ जी. Just a minute. Just.
Yes, participants, if you're comfortable with the morning session tomorrow, we can schedule it as per your convenience in the morning time, provided all the participants agree. Otherwise, we will have the sessions at the scheduled time. So we just wanted to have an idea uh, how many of the participants they are comfortable with the morning time, or if anyone is having any objection in the morning time, please give us the idea regarding that. Is there any participant who is not comfortable with the morning session tomorrow? Please let us know.
I think there are very few participants right now, so probably on the WhatsApp group. I don't know.
Okay, we can
'Cause,
decide it. Yeah, we can decide it in our WhatsApp group
yeah, there are quite a
only.
few.
I think,
Yeah.
yeah, some of the participants they are not here in the meeting. Yes, we'll decide it and finalize it accordingly. Otherwise, if no consensus we reach again, we'll be having the same the session at the same time.
Fine.
Okay, then participants will disperse for the day. I think Jaspreet ma'am has lost the connection. Okay, participants, that means we'll decide in our group and then we'll meet again tomorrow.
कविता मैम अभी मेरी जसप्रीत मैम से बात हुई है and she's saying for tomorrow's session can we start at 9 o'clock 9 to 10:30. She just called me. She's saying if participant is ready then we can continue at 9 o'clock for tomorrow.
Okay, then yes, ma'am, that's what we decided right now. We will deciding it in our WhatsApp group and finalize it accordingly.
ठीक है ओके चलो
Okay, participants, we all may disperse. Thank you so much.